Hello, my name is Chris Williams. This is my second presentation for predictive policing using Chicago crime data. In this presentation, I'm going to cover how the data was collected, cleaned, merged, and prepared for exploratory analysis and modeling. The data sets for this project come from the City of Chicago data portal, which provides open access crime data through both downloadable CSVs and a live API. The data is reported at the incident level, meaning every row represents one reported crime. To protect privacy, street addresses are masked at the block level, and all data must comply with the City of Chicago's data terms. For this project, I focus on the time span between January 2001 and August 2025, capturing long-term crime trends across multiple neighborhoods and seasons. The ETL process. The data extraction, transformation, and loading, or ETL process was performed entirely in Python using pandas. Data was extracted in 5-year increments because the complete data set is too large for tools like Excel. Each file was transformed by standardizing column names, parsing dates, and removing invalid entries. Then all the files were merged into a single master data frame for consistency. This process was designed to be reproducible and could easily be automated using the Socrata API for future updates. Data integration. During integration, each data set was validated for shape consistency, missing values, and matching schema. Because file sizes were massive, I relied on Pandas' optimized data handling to efficiently merge them together. The combined data set produced a single data frame and all the filtered subsets used for testing. All merge options were verified by comparing record counts and unique IDs to ensure no duplication or row loss occurred. Initial data profiling. Before cleaning, I conducted an initial data profile to understand its structure. The dataset spanned from early 2001 through mid-2025 and included 31 unique crime types. The categories include theft, battery, criminal damage, assault, motor vehicle theft. Each key field, like data, primary type, and location, was checked for completeness. The result, no significant missingness, and only a small number of rows had out-of-bounds coordinates, which were removed. This shows that Chicago does a good job of entering their data. Missing data and consistency. Cleaning focused on accuracy and consistency. Dates were parsed using strict coercion rules to handle invalid timestamps. All text fields were standardized to consistent capitalization and category names. Row missing critical fields like date, primary type, or location were dropped rather than imputed to ensure model integrity. Finally, geographic fields were validated within known Chicago boundaries, so any coordinates falling outside of the city were excluded. Outliers and variable reduction. To improve modeling performance, I reduced variables to the most relevant ones. Time fields like year, month, day, and hour, as well as location indicators like district and community areas. Outliers were defined as impossible coordinates or future timestamps. If the timestamp is in the future, then it was fat-fingered in. Duplicate reports, if any, were removed by checking unique identifiers. The resulting data set maintained all necessary structures for modeling while reducing noise and improving interpretability. Data splitting and wrap-up. The final data set was partitioned by time into training, validation, and testing sets. Training was 2001 to 2022. Validation was 2023. Testing was 2024 and 2025. This chronological split preserves a temporal sequence of events, which is essential for predictive modeling. A reproducible data pipeline was built so that these steps could be rerun automatically when new data is released. Closing. In summary, this page ensured our data is accurate, consistent, and ethically compliant. By automating the ETL process and standardizing formats, I created a reproducible foundation for the next steps: exploratory data analysis and feature engineering. In the next presentation, we'll cover the spatial and temporal patterns within the data, i.e. the geo and time, within the data, and engineer the features that will drive our predictive policing model.